Today we're going to do triangle congruency again, day 2. So let's remember that last time we learned side, side, side for a postulate. We learned side, side, and we learned angle, side, angle. Those were all postulates. Today we're going to learn 2 theorems. So the angle, side theorem. And so what that one says is if you have an angle like A and D that are congruent, and you have C and F that are congruent, and a non-included side. So this side is non-included, CB and FE. Okay, if you've got 2 angles that are congruent with each other and then a non-included side, then the 2 angles still are congruent by this theorem, angle, side congruence theorem. And our final one is the hypotenuse leg congruence theorem. If you have a right triangle, the side opposite the right angle is called the hypotenuse. It's the longest side of the triangle, and the other 2 sides are just called legs. So you've got 2 legs, and the longest side is the hypotenuse directly across from the right angle. All right, in this theorem, if you've got a leg, either of the legs that are congruent with each other on the 2 triangles, and the hypotenuse, this is the hypotenuse, and this is a leg, and this is a leg. All right, so it's saying that CA is congruent with FD. And also it's saying AB is congruent with DE. And because if you have those 2 things given to you, then you can say the 2 triangles are congruent by the hypotenuse leg theorem. So let's do some examples. All right, we're going to identify what's going on here. All right, so here I see we've got a congruent angle. We have another congruent angle, and we have a non-included side. So that is congruent by angle, side, those 2 triangles, the angle, side theorem. All right, how about this one? We've got a side that's congruent, and those are, I see the right angles, so those are the hypotenuses. And we also know that these legs are congruent because it's the same side. So we've got legs that are congruent, so by the hypotenuse leg theorem, those are also congruent. So we could say angle RSA, triangle RSA, is congruent to triangle TSA by the hypotenuse leg theorem. All right, here they're just giving us 3 angles that are congruent with each other. We already talked about that. If that's all they give us, then there is not enough information to determine that these are congruent. On number 4, we have 2 angles that are congruent. We've got another set of angles that are congruent. We've got this side that's congruent. We've got these sides that are congruent. So can we prove that they're congruent? We've got an angle, side, so that would work. And we have a side, that's probably all I can see, angle side. So these are congruent. So let's say ABC, triangle ABC is congruent with ADC by the angle side theorem. Let's find the value of x so that the triangles can be proven congruent. So when it's written that way, it's trying to say, how do we prove the triangles are congruent? Well, we're going to have to prove one of these theorems or postulates occurred. So if we can find x in such a way that we can tell that all the sides are congruent, then we have side, 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 right? So let's go ahead and put 4x plus 8. In order for these to be all congruent, this one's going to have to be congruent with this one. This one we already know is congruent with itself. And they already told us these bottom ones are congruent. So let's make this one triple. Alrighty. So we need 4x8. As long as we can prove that these two sides are congruent, then we have side, side, side. All right, so we have x equals 4. So we've got 16 plus 8 here. If we were to plug this x equals 4 back in, we know these would be equal because we've already set them to be equal, but we're going to have 16 plus 8 here, 24. And we're going to have 28 minus 4 here, which is also 24. So x has to be 4, and then these can be proven congruent by side, side, side. All right, how could these be proven congruent? Number 6. We've got the two angles that are congruent, side, angle, side. So as long as we can make those two sides equal to each other, then we will have side, angle, side, and we can prove them congruent to each other. All right, so let's subtract this. We want everything on the same side as each other. So let's move this over. And move this over. Sorry. I got a little distracted there. Okay, so now we can set it up for factoring, okay? In order to factor, we'll need this 8 on top, negative 6 on bottom. What two numbers can be multiplied to get 8, but also added to be negative 6? That would be 4 and negative 2. So we'll have our factors of x minus 4 and x minus 2 equal to 0. How do we solve and just get x? We're going to have to set them both equal to 0. X equals 4 and x equals 2. Those will be our two solutions.